Those of you already joined in, make sure and check in week 2 and then come back to the Kahoot. It's on the screen in front of you and join it. We'll get started here in about 3 minutes. Those just joining, make sure you go to PCT130 week 2. There's a check-in module. Put your full name in there, and then come back to the video, live stream video, and there's a Kahoot with a game pin. Go and enter in the game pin. Go to kahoot.it from your phone, tablet. Enter in the game pin, and you know the drill. Put in a superhero name or your favorite artist you've always wanted to be, maybe. Something like that. This is going over Chapter 2's content. We'll get started here in about 2 minutes.
Okay, we'll give it a couple more minutes before we get started. I'm going to go ahead and email everybody just in case. Going over Chapter 2's content with the Kahoot. Make sure you've checked in. Looks like the snow has started. All right, I just emailed everyone just to make sure. We'll give everyone another couple minutes before we get started. This Kahoot is over Chapter 2 content. This Thursday, if we have class, hopefully we will, we'll do our first lab on the NT reset. Bring your 3-ring binder if you have one. If you don't have one, it's not required that you bring one, but it's just nice to put your handouts in there and your software. And you will be getting some software Thursday. All right, we got 4 connected. I'll give another. I got 4:31 on my end, so we'll give another minute. I just emailed everyone, those that are attending. All right, I'm going to go and get started. We got 5 of you, I believe, connected. All right, so this is over Chapter 2 content. Let's begin. 13 questions. Malware is unable to install itself and require host program or human to propagate. Botnet, bug, worm, virus. The answer is virus. Viruses need a host program to run every time, like say it's an email virus. Every time somebody opens an email, it propagates that virus. Next, here's a leaderboard. Yes, good job. Malware that can spread by itself to other computers on a network is called a worm, botnet, virus, or bug. It can spread it by itself is the key words. By itself. Worm is a correct answer. Worm can go from server to server, computer to computer without any help from any other program or process. Next. Malware that controls multiple computers at once using a control center is called a botnet, bug, virus, or worm. Controlling multiple computers might help. Botnet is correct. Next, using random guesses and computation power in order to decipher messages called brute force hacking, combination hacking, trial and error hacking, power hacking. The answer is brute force hacking, where it uses basically random passwords, thousands, sometimes millions of them, one right after the other. The faster it can try a password, the faster it can crack the password. Satan L has the highest answer streak of 3, and yeah, still in the leader. Blank attacks use millions of computers to overload a network, which causes it to shut down. DDoS, DOS, HTTP, rootkit. The DDoS is a denial of service attack, and a lot of times happens on web servers and such to bring a server down. Leaderboard. A blank puts a piece of code in the operating system to gain escalation of privileges. Rootkit, worm, Skynet, malware. The keyword on this is escalation of privileges. Rootkit is the answer on that one. And like in the Linux world, root is actually the admin default password. And the term root, a lot of times in networking, is used for someone or something that has administrative rights. So a rootkit's damage is done on a server when it tries to escalate or does escalate privileges and different processes to override network control. The blank monitors what comes in and goes out of your computer's network. Firewall, botnet, antivirus software, CPU. It's also the first defense of any network, generally. Firewall is the answer. 2 types of firewall. You have software firewall built into your operating system, and you also have hardware firewall. Cisco makes them. They're the main provider now, but other ones are out there as well, and set up rules to guard outgoing and incoming data. All right. A blank can scan your files to find and remove malware on your computer. Antivirus, firewalls, anti-establishment, routers. Antivirus is correct. 100% right on that. Good. Next. Leaderboard. Blank record records every key you push so a hacker can see everything you type. Keystroke logger, adware, rootkit, keyboard recorder. Keystroke logger, keyboard logger is also another one. Could be answered. A company may put a blank to quickly fix a previous vulnerability. Fix, patch, update, new version. First guess is usually, yep, perfect. So patch is correct. Microsoft puts out patches for its OS. Apple puts out patches. Your phone puts out patches for quick security fixes all the time. A blank is a hacker that uses another person's code without understanding how it works. Script kiddie, newbie, kitty coder, white hat hacker. Script kiddie is the term, and a lot of times they'll download predefined utilities already designed by hackers without any knowledge of how it works. They know how it works, but not how it was created. A blank hides in another program that users install willingly, but then it strikes. Worm, spyware, Trojan horse, adware. Trojan horse is the answer. A fake email that asks for your password is an example of a phishing scam. And there is the score for the first time. And so, again, these aren't graded, so good job, everybody. Now let's jump to week 2. Hopefully you've already checked in. If you haven't, do so after I'm done here. I'm not going to keep you real long. Tasks for this week. We'll be going over chapter 2 tonight, in-class lab Thursday, and then you have due by Sunday review questions and quiz. The podcast that we're doing now, that's going to be the lab for Thursday. Those of you who do have a Mac, there is steps in here. We won't do this in class of how to reset a Mac OS admin with terminal. We'll be using a tool called anti-reset. And then review questions, the back of your chapter 2. There's review questions. I just need answers only. Okay, and I've got some notes to go over tonight with chapter 2. So I will bring those up. And I will go full screen. All right, this is malware and social engineering. So we went over some of these already in Kahoot. We're going to go over some of the terms as it pertains to things that can hurt your network, things that can harm your computer, your phones, and some of the words definitions, so terms definitions. So first is malware. Malicious software enters a computer without the user's knowledge. It refers to a wide variety of damaging or annoying software. Objectives for malware is to infect a system, conceal its purpose, and make profit. Malware tries to and does succeed in having people buy software that really doesn't do what it says it's going to do, or stealing information sometimes behind the scenes, like your data, i.e. Facebook. We got in trouble for that. And so it can actually be damaging or just annoying in its attempt to conceal itself. Viruses is malicious computer code that replicates itself on the same computer. Generally, a virus is attached to a file, like a Word document, an Excel document, a movie file, an MP3 file, an email, and anytime anyone opens it, it replicates itself. The virus infection method, the Appender Infection, is where the virus appends itself to the end of a file, moves 3 bytes of the original file to the virus code, replaces them with some instructions pointing to the virus code. So the program or the process runs like it normally does, but somewhere in that first launch, it launches the virus attack as well. Swiss cheese infection is a virus that injects itself into executable code. The original code is transferred and stored into a virus code. The host code executes properly after the infection occurs. Split infection is where the virus splits into several parts. Parts placed at random positions in a host program. The header file of the program then gives control to the next piece of the virus. When a program is infected, a virus replicates itself by spreading to another file. It activates itself by some malicious payload. We'll say the payload is collecting your data, your keyboard logger data, screen scrapes of all your activity, just to name a couple. It also might just display an annoying message. Examples of virus actions could cause a computer to crash repeatedly with a blue screen of death on Windows, erase files or reformat a hard drive, or turn off your computer security settings altogether, and even turn off your antivirus. This is kind of a funny initial virus back in 2012 that was just a message that popped up all over people's screens. And I'll go ahead and read it. It says, I think I speak for every pot smoker in North America when I say legitimize marijuana. I mean, if people with AIDS, cancer, and other diseases can use it, then why can't the rest of us pot smokers use it? I don't think that's very fair to you. If it's legal to grow and use in places like Australia for personal use, then why not in America, North America? Doctors are using it as a treatment for illness, and it must not be that harmful. So why can't other people use it? I really do think the federal government should consider legalization of marijuana. Well, that's really all I have to say on the matter, but I do hope someday, somewhere, someone listens to what I have to say and doesn't just regard this as just another virus, because it's more than that. It's a message for freedom. The freedom to smoke up and to have the choice, or chose, to do so without the fear of punishment for the law and government. Thank you for your time. You'll notice, first thing, a lot of grammar mistakes. I'm not an English major, but I know enough of English to know that. A lot of times when folks create viruses and there is messages within the viruses, a big red flag that it's a virus or that software or something that's not legitimate is misspelling, run-on sentences, and nonsensical nonsense like this. So malware also, or when it comes to viruses, cannot automatically spread to another computer. It relies on some action, like opening an email. And say the virus, when you open your email, reads all your contacts and then sends that email to all your contacts in your email contact list. That would be an example of what a virus can do and how a virus is spread. Viruses are attached to files like an email, and viruses are spread by transferring infected files. Today, the number one way viruses are spread in a network on a business, school, or otherwise is via email. That's the number one way. Many people don't use USB drives anymore. Many people don't download free programs. Not to say people don't download programs to their computer, but the number one way viruses are spread, the ones we're talking about here, is through email. So types of viruses, computer viruses: program viruses, infects the .exe, the executable. Macro will be like in Excel. When you open up an Excel document, sometimes it'll say, this file has a macro. Do you want to run it? And macros can be good, and they can also be evil. A macro is actually code behind the scenes of an Excel document that can control your computer. It can download files. It can erase files. It can do a number of things because it executes a script, which is basically an app within Excel. A resident virus affects every time a person opens an operating system. So these types of resident viruses, usually the computer gets slower and slower and sluggish and more sluggish over time. Boot sector is another one that affects the MBR record of your computer. That these can actually infect memory modules, can get to the memory module state of a motherboard. And then companion virus adds malicious copycat program to the operating system. Copycat program would be such as an antivirus program that says it's McAfee or whatever, but it's not, but it has the icon of McAfee. It looks like McAfee. It spins. It acts like it's updating, but it's a copycat program that when you reboot a computer after this is installed, it disables a real McAfee and now it's running the malicious McAfee, which doesn't block anything from your computer, any malicious activity from your computer. And then the hackers can go in and do their dirty work with that companion virus. A worm is a malicious program that exploits apps and OSs. It sends copies of itself to other network devices. It may consume resources, and meaning when you go and your computer's always slow and you look at the CPU processes and it might be like at 90% or 99%, it's constantly running in the back end. Examples of worms are deleting computer files, allowing remote control of a computer by an attacker. This is why I said it's important to shut off a computer at night. One of the number one ways that these types of worms are propagated are between midnight and 6 in the morning. And it's not to say that gets rid of the worm, but at least it can't do any activity until, and not only that, but activities to install the worm generally happen between midnight and 6 as well. So here's a good diagram on some action, what virus and worms. So difference between a virus and worm. So action, how does it spread on a virus? It spreads by transferring files. Worm travels from one computer to the next via network. How does it infect? A virus inserts code into a file. A worm exploits vulnerabilities in the application or OS. Does there need to be user action in a virus? No, or yes, meaning they have to open up an email, open up a document. No user interaction is needed for a worm to do its deed. Can it be remotely controlled? A virus cannot, but a worm can. Trojans. A Trojan basically is a program that advertises to do one thing but does another. It's typically in games, free games that people download, or free utilities, both for computers and for mobile devices. It generally targets on the mobile devices Android, because the Android store doesn't filter as secure as Apple does when it goes through and approves applications and software. It typically, though, is made to appear as a data file. An example, the user downloads a free whatever program, in this case, a calendar program. The program runs, scans system for credit card numbers and passwords, and then transmits it to an attacker on the back end, while the person is using a free computer program. Rootkits. This is actually one of the most malicious for servers, and in my experience, a lot of times the entire drive will need to be replaced because of the traces of a rootkit can be really, really deep and very difficult to get rid of. But it can go in and escalate itself as an admin and alter system files, alter settings. And it can be detected using batch files that have a whole bunch of commands in them to delete files, get rid of files that should be that's part of a rootkit. Maybe very difficult to detect, and they are generally very difficult to detect. And it must be erased, meaning every file must be removed, and that's where the difficult part comes in. And like it says here in the slide, Original OS must be restored, and also reformatting a hard drive or reinstalling the OS, or in my experience, even replacing a hard drive a lot of times is the best solution. A logic bomb is where computer code lies dormant to a certain date, like say Valentine's Day coming up or 9/11 is an example. Difficult to detect because nothing is happening until that date. Backdoors where software circumvents normal security. Usually backdoors are developed by developers. And me being a developer can tell you we put backdoors in software so we don't have to go through the front end while we're coding and while we're making changes to things. And so a lot of times developers will put a back end backdoor in an application. An example might be clicking on the logo on the front screen of an app 10 times and then typing in the numbers 794, something like that. And then you're into the software. That would be an example of a backdoor. Famous logic bombs, and by the way, backdoors are usually leaked out by disgruntled employees, i.e. developers, that leave a company because they were passed over on say a promotion or something or a project, and they'll do that. And so here's some famous logic bombs. A logic bomb was planted in the financial services computer network that caused 1,000 computers to delete critical files. The reason a disgruntled employee counted on this to cause the company's stock to drop. The employee would earn money from that price drop. Result, the logic bomb detonated, yet the employee was caught, sentenced to 8 years in prison in order to pay $3.1 million in restitution. Second example, a logic bomb at a defense contractor was designed to delete important rocket project data. The employee's plan was to be hired as a highly paid consultant to fix it. The logic bomb was discovered, disabled before it triggered. The employee was charged with computer tampering and attempted fraud and was fined $5,000. Third example, a logic bomb at a health services firm was set to go off on an employee birthday. The employee was angered that he might be laid off, although he was not. The employee was sentenced to 30 months in federal prison and paid $81,200 in restitution to that company. So malware for profit, botnets, spyware, adware, and ransomware is a new one that's out now. That's been out for a while. Not real new, but it's been out for a while. All of these are designed to make profit. A botnet takes over many computers, and its job is to basically use the power of those computers for computational purposes, or to take down a government, or to take down a company. Early botnet attackers used Internet Relay Chat, IRC, to remotely control zombies. And then open HTTP port 80, which every computer has open, is often used today. The advantages for attackers on botnets is operates in the background, no visible existence. It generally runs at night when people aren't on a computer, so early in the morning. It can conceal activity, can remain active for years. And a large percentage of zombies are accessible at any given time due to people's computers being on all the time. So here's the use of botnets and spamming. Thousands of zombies enable attacker to send massive amounts of spam to harvest email addresses. People buy email addresses. Number one way folks make millions and millions of dollars today, maybe even billions, is selling your data. Spreading malware. Botnets can be used to spread malware to create zombies. Botnet zombies have the ability to download and execute a file to send an attacker. IRC networks, not so much used anymore today, where they can remote control many computers. Manipulating online polls. We've heard of this lately in voting, both in the US and overseas, where each zombie has a unique IP address. Each vote by a zombie will have the same credibility as a real vote. Online games can also be manipulated this way. And then denying services. Botnets can flood a web server with thousands of requests to overwhelm it for a legitimate request. Spyware, not so much heard of anymore. Spybot and Destroy is a popular software that can get rid of this if you do have some. But it generally was 3 or 4 years ago really popular to advertise, collect personal information, changing computer configurations, and it usually popped up all over your computer. Negative effects, low performance, instability of the system, many toolbars on a web browser. I heard one mom that had her son was trying to do schoolwork. He was taking forever and he wasn't getting anything done. And she walked down and looked at his computer. It had about 8 or 10 toolbars stacked right on top of each other. He only had room at the bottom of the browser about 1.5 inches to see any data. That's not good. And this is what spyware was very popular. And it's still out there too. If you download software today from the web, a lot of times it'll have spyware built into it. That'll have all these toolbars they want you to install. Even though you get a free software, you have to install all these toolbars, which takes up your not only a browser interface, but it can also cause pop-ups. It can cause your data to be stolen, all of those things. So I always warn people when you download anything from the internet, make sure you're not installing all these extra toolbars. I recommend downloading software from a legitimate app store. In Microsoft, it would be Microsoft, Apple's App Store, your phone's App Store. And unless you're a developer, that's going to be the safest place to buy or to download apps. Technologies used by spyware: automatic downloading of software without the user's knowledge or interaction, passive tracking, gaining information about where you visit websites, where you go. And then they could sell that to marketers, by the way, and get millions of dollars for that data. You wonder why you're getting mail targeted exactly to what you normally shop for, is because sometimes it might be this. You filled a form out, it got your email, it installed a software that now tracks some stuff you do on a computer. Tracking software monitors behavior about the user, personal identifiable and other sensitive information. And then that data can also be sold to the highest bidder, and even identity theft can occur. Adware, again, not so much around as much as it used to be years ago, but it's definitely used to still in email for phones and social media. Adware is where it's designed to pop up advertisements on what you normally talk about on the web, and via email or via Facebook. When you're chatting about whatever, it reads your words and then targets you about what words you normally type in. So if you're typing stuff about football all the time, you're going to get ads about football, gear and deals for trips and all this stuff. And that's why you're getting them, is adware. Downsides of adware: you might get some objectionable content sometimes, depending on what your search habits are. You could get pop-ups that could cause low productivity and crashing your computer and slowness of a computer as well. Keyloggers. The general way keyloggers are today are different than they were 10, 20 years ago. When keyloggers first came out, you had to have a hardware device that plugged in the keyboard or a serial port in the back of the computer. It would then log the information as the people typed in the user keyboard. Then you would pull the device out, and then you would gather that data that was collected. Today, keyloggers a lot of times downloaded from freeware sites, peer-to-peer sites, questionable gambling sites, and so the attacker can use that information for password entry, credit card entry, bank entry, personal information. And again, like on the slide, it talks about a small device. Generally not so much today. A hardware device is generally going to be a software device that's downloaded. That's what the hardware device look like. You'll notice the keyboard is plugged into this device, and the keylogger records clear text every keyboard or every keystroke pressed on a keyboard. Here's a software based called Capture Keylogs. where you basically put in the email of the person you want to send the data to, and it sends all the information. Social engineering, the number one way that attacks occur today still, is where individuals gain trust of other individuals to gain information. The goal is for information. Flattery, flirtation, conformity, friendliness, and all the above, basically, whatever it takes to get the sale, which is data. Attacker will also ask for small amounts of information, often from several victims, to make sure it's correct. Request needs to be believable. Attacker will push the envelope to get information and may smile and as they ask for help. A popular social engineering attack on a phone, via phone to businesses, is somebody guising as an administrator for a large box store, saying that they are coming in the morning early at, say, 5 a.m., need administrator access to a server on site, and wanting to know if they can get that access from somebody. The person on the other end is just leaving. They usually call around 5 o'clock, by the way, and they're not going to be there till the next morning around 9. This person on the phone asks if they can come in early to help them, or just give them that information so they can do it themselves. Awkward pause. The person gives them their information, username and password, leaves for the day, comes back. When they come back in the morning, the system's already been hacked, data's already been taken. Whether it's known or not is sometimes in question, but it happens every day. Social engineering attacks like that. True example of a social engineering attack: one attacker called human resources, asked for and got names of all the key employees. Small group of attackers approached the door of a building, pretended to have lost key code, was let in by friendly people, trusting Americans like us. Entered another secure area in the same way. Group learned CFO was out of town because of his voicemail greeting message. Group entered CFO's office, gathered information from an unprotected computer, dug through trash. One member called help desk from CFO's office, pretended to be the CFO, asked for a password. Help desk gave the password. The group left the building with a complete network access and a whole bunch of data files. Impersonation. The attacker pretends to be help desk, a repair person, a trusted third party, printer repairman, you name it, a computer repairman or woman, you name it. Phishing, another way social engineering, where an email looks legitimate, a website looks legitimate, people enter in the data, they think it's to their bank or credit card, but it's going right to the attacker. Variations of phishing, email, already mentioned. Whaling is where you go after big fish, targeting wealthy individuals. Phishing, voice phishing, attacker calls, like a record a bank message or, a security. My name is, I have the administrative security captain of the FBI calling with account number 5632. You have to call immediately or the sheriff will come. Stuff like that. And wanting you to call back to scare you into giving you information, or you giving them information like your bank account to take money out of your bank. Example here of a phishing message, again, looking a lot like a credit card from eBay or email from eBay. And you might already know this, maybe you don't, but companies will never send you an email like this to click something, to reset a password, or to verify yourself. They won't do this because of all the phished attempts. Any doubt, you can call the company, get the direct line, and let them know about it, what's going on, so they can follow up on it. Continuing on social engineering attacks, you have deceptive web links that look like something, but they're something else. I always tell students and people I know to hover over the link, whether it be an email from somebody saying they're from somebody. You look at it and it's not that domain. presence of vendor logos that look legitimate, or even a lock on a website that's just a simple GIF file. Anybody can do that. Unsolicited email, targeted instant messaging, text messaging targets are real popular with cell phones. And then they have a thing called, with instant messaging or with email messaging called layering, where it layers the image in a email to where it bypasses the email filter. Split wording, where it splits words, can easily be read by human eye, can't be read so much by email filters. And geometrics variance is where you use different colors so no two emails appear to be the same. Here's an example of an image spam. The entire email, except for the bottom text, is an image. Hoaxes, false warning or claim, may be first step in attack. Physical procedures, dumpster diving, where people literally dumpster dive in businesses to find data. That's why it's real important to shred everything, even home users. Important to shred. A shredder does not cost a lot of money. Make sure you're shredding all documents that have your name, address, and contact and account information. Is a good idea to shred that. Tailgating, following behind an authorized individual through a building or access door. And then dumpster diving, I already mentioned some of the things you can get. Everything from calendars to memos to charts to phone directories to policies to system manuals. A tailgater could ask somebody to hold the door, waits outside the door, enters authorized when the employee leaves. Shoulder surfing, looking over as somebody enters in a keypad code. So in summary, malware, software that enters the computer without the user's knowledge. Malware spreads includes computer viruses and worms, and it can also be concealed with such things as Trojans, rootkits, logic bombs, and backdoors. Malware with profit includes botnets, spyware, adware, and keyloggers. So that's chapter 2 content. And by Sunday, let's look at the syllabus. You've got week 2 quiz, the lab on week 2. Make sure and bring a binder if you have one, and then review questions. Next week, we'll talk about week 3. You're going to be picking the research paper topic. So thanks for joining tonight. If you have any questions, you can definitely shoot me an email. Otherwise, be safe outside if you have to travel tonight. Hopefully you don't. And we'll see you Thursday.